Let's get started with the practice test for Unit 3. This is on matrices, and it says show all your work and thinking just like normal, and we're going to need to circle our answers. First part says state the dimensions and find the indicated element for each matrix. If this is not possible, we want to make sure that we state why. So on this one here, we've got matrix A. We've got 2 rows. Remember, it's always rows then columns. So we've got 2 rows and we've got 3 columns. So this is a 2 by 3. And then we want the A13 elements. So that's going to be first row, third column. So first row, third column is going to be right here. So that ends up being a 0. Take a look at B. We've got 3 rows here, and we've got 1 single column. So this is a 3 by 1. And we need the B11 element. So that's going to be the first row and first column. So that's going to be that -7 right there. This is a square matrix here. We can see that we've got 3 rows and 3 columns. So this is a 3 by 3, and we need the element in the C32 position. So third row, second column. Third row here, second column. That's going to be the 5. And then this one is, well, this one's kind of weird. It doesn't have any numbers in it. It's just got an X and Y, but it does have 1 row, and then we have those 2 columns here. So this one's going to be a 1 by 2, and we need the D21 element. So that means second row, first column. Well, we don't have a second row, so we're going to put NA, not applicable, and we're going to state why. So we'll just say no second column. All right, on to the next part here. Let's go ahead and take a look. It says perform the indicated matrix arithmetic. If the operation is not possible, state why. So if we can't do it, we want to make sure everybody knows that we know why it doesn't work. So on this right here, we've got some scalar multiplication. So it's basically like distributing. So we're going to get a 2 by 2 matrix that's the solution, and we're going to multiply every one of these elements by 4. So this is going to be a 12. This is going to be a -20. Multiplying here, we get a 16, and 4 times 0 is 0. So there's our answer right there. Next one here, we've got a combining problem. We're going to be combining this matrix with this matrix. This is a 2 by 3, 2 rows and 3 columns. We're combining it with a 2 row and 3 column matrix. So we do get a 2 by 3. So 2 rows and 3 columns, and then we're just going to add here. If this ends up being a subtract like we do down below, we're going to need to be careful. So this is going to be 3 plus a -4, so that's going to be a -1. We're going to have a 2 plus a -3, so that's also a -1. And then we have 3 plus a -2, so that's going to be a +1. We've got a -2 plus a 5, so that's going to be a 3. And then we've got a -1 plus a -1, so that's going to be a -2. And then we've got a -6 plus a 6, so we end up with 0 there. So there's our answer resultant matrix right there. This one is 1 row and 3 columns, and this is two rows and 1 column. We can't do that, so we're going to put NA here, and we're going to state why. They don't have the same dimensions, so we'll just say not same dimensions. Not the same dimensions. All right, so there's the answer on that one. And then down here, again, some scalar multiplication. This is a piece of cake just like we had up there. We're just multiplying in by a -2. It doesn't change the dimensions of the matrix, so this has 1 row and 4 columns. We're still going to have 4 entries here in this first row, so this is going to be a 10, a -10, a -6, and a -2. Again, it's just basically distributing in and multiplying each one of those by that scale factor there. All right, let's slide down here and take a look at 9 and 10. Here we've got some scalar multiplication, and then we've also got to combine the results of that scalar multiplication. So we do want to be careful here. Again, we're just going to go ahead and distribute through here. Might not be a bad idea to kind of take a look and say, hey, can we actually combine these once we're done with the scalar multiplication? This is going to be a 2 by 3 here. The other one's a 2 by 3 on here. So we actually can combine these. So let's go ahead. We're going to distribute through here with the scalar multiplication. So we have a 2, a 4, and a 6, and a -4, and a 0, and a -12. Now what I'm going to do next is kind of personal preference. This has a -3. We could just distribute the 3 through, but I'm actually going to distribute the -3 because it generally makes it a little bit easier if we're adding these matrices together. So this is going to turn into a 6. This is going to be a -9. This is going to be a 6, a -12, a 3, and a -15. So you can kind of see what happens here. We end up just changing the sign of each one of these numbers, multiplying it by 3, so tripling each one, and then we're just going to add these together. So again, a 2 by 3 plus a 2 by 3 is still a 2 by 3, so we end up with a 2 plus the 8, 2 plus the 6 is 8, thinking ahead there. 4 plus a negative 9 is going to be negative 5. And then we've got 6 plus 6, this would be a 12. Negative 4 plus negative 12, that's going to be a negative 16. We've got 0 plus a 3, so we get a 3, and then we get negative 12 minus 15, or plus a negative 15 if you want to think of it that way. We end up with negative 27. So there are the 6 elements in this 2 by 3 matrix that we get as a result there. This one's a little bit quicker here because we've got smaller matrices. This is a 2 by 2 on this one. This is a 2 by 2 on the next one. So we can go ahead and do the scalar multiplication and then combine these. I'm going to do the same thing again. I'm going to write down what we get when we do the scalar multiplication. So that's going to be 12, negative 20, 16, and 0. I'm going to change this to plus. So what I'm doing effectively is I'm distributing a negative 2 through there. So we end up with a 2, a negative 2, a negative 2, and a 2. All right, and then we'll go ahead and combine these. So let's see, we've got plenty of room off to the side here, so we'll write it there. We've got a 12 plus 2 in that 1 element, so that's going to be a 14. We're then adding element by element here, so that's going to be a negative 22. And then we've got 16 plus a negative 2. 16 minus 2 is 14. And then we have 0 plus 2, so we end up with a 2 right there. So there is our result. So you can tell that these go pretty quickly here. Continue sliding down here. This is the end of the first page. What we run into now is you'll notice that there's nothing in between the two sets of matrices. Unlike what we had up above where we had some operations, there's nothing in between here. So this is implied multiplication and this is matrix multiplication. So we need to be really careful on problems like this. We need to make sure that the inner dimensions are the same. So this is a 2 by 3. This is a 3 by 2. So those inner dimensions are the same. The number of the number of columns in the first one is the same as the number of rows in the second one, so we can multiply these, and the resultant matrix would be this 2 by 2. So we're going to have a 2 by 2, and again, if it's helpful, if you need to write down these little slots right here, go right ahead and do that. We know we've got these 4 to fill in, and here's what we're going to do. This one right here is the first row, first column of the resultant. So we're going to take the first row and we're going to multiply it with the first column element by element, kind of multiplying in those corresponding orders. Sometimes I call this the karate chop method. So we're going to take this row right here and we're going to multiply it with that column right there. So when I do that, and I'll show a bunch of work on this one, so we're going to have a negative 1 times a negative 7, so that's going to be a 7. We're going to have a negative 2 times a 1, so that's going to be a negative 2. And we're going to have a 5 times a negative 6, so that's going to be a negative 30. So when we put those together, this would be negative 32 plus 7, so that's going to be negative 25. So we'll put a negative 25 there. Now we're going to take this. We're going to find this one here. It's in the first row, second column, so I'm going to take the first row and I'm going to multiply it with the second column. So again, I'll show the work down here. Negative 1 times 2 is negative 2. Negative 2 times 0 is 0, and then let's see, 5 times 3 is going to be 15, and this is positive here, so we're going to combine these together, and we end up with 13, so I'll put a 13 right here. And now this one here, this is in the second row, first column, so we are going to take the second row, and we're going to multiply it element by element in that corresponding kind of karate chop method order. With that first column there. So we're going to multiply the 3 times the negative 7, and we get 21. We get 4 times 1 is 4, and 0 times 6 is 0. So if we combine those together, we end up with a 25. So we've got 25 right here. Let me get that to come back, 25 there. And then this last one here is in the second row, second column. So I'm going to take the second row, and we're going to multiply that with the second column. So when we do that, we end up with a negative 3 times the 2, so that's going to be negative 6. 4 times 0 is 0, and 0 times 3 is 0, so we end up with a negative 6 in this position right here. Now, if you put these little blanks in there, that's totally okay. You can leave them if you want. I don't really care. but this is the final answer. That's what we get when we multiply the two of those together. Again, if the inner dimensions are the same, the resultant is going to have these outer dimensions. It's going to be a 2 by 2. You're not required to write the dimensions on the resultant, but you can if you want. So we'll take a look at this one. What we've got here is, now this is kind of interesting. Notice that these are flip-flopped here. You normally can't do matrix multiplication. It's not commutative. You can't flip those things around. And let's take a look at this and kind of re-verify why you can't do that. This one is a 3 by 2. And this one is a 2 by 3. So we can multiply these, but you can tell automatically we're going to get a different answer because the outer dimensions are 3 by 3. So we're going to end up with a 3 by 3 determinant. So if that's a 3 by 3, we're going to have 1, 2, 3 in the first row, 1, 2, 3 in the second row, 1, 2, 3 in the third row. So just by switching these, we get a completely different result and heck of a lot more work to do. So let's see if we can speed this along here. We're going to take the first row and we're going to multiply it with the first column to get that element in the 1, 1 position. First row, first column. Now, if I need to show work for this, I would, but on this one, I think we can keep track of these two things in our head. So when we multiply the -7 times the -1, that's a 7. 3 times -3, or sorry, 2 times -3 would be -6. So this is going to be 7 minus 6. So the resultant there is going to be a 1. Now we're going to take the first row and we're going to multiply it with that second column. So we're going to multiply here. Again, keeping track of this kind of in our head, this is going to be a 14 and an 8. 14 and 8 is going to be 22. So we get 22 right here. Next one, right here, we've got first row, third column, and you can kind of see the patterns of what's going on here. So we've got, let's see, this is going to be a -7 times 5. That's going to be -35. 2 times 0 is 0. So we end up with just a 35 on that one. And it is a -35 if I misspoke, so -35. So I'm going to go ahead and erase these, and instead of highlighting these, I'm just going to use the same color as I do on these other ones. So this is second row, first column, second row multiplied with the first column. This is going to give us a -1 and a 0, so we end up with a -1 here. We're going to do second row, second column, so we're going to multiply here. So this is going to be a -2 and a 0, so this is working out pretty nicely. That's not too bad. And then we're going to go with the third column here. It's this one's turn. So we're going to get a 5 and a 0. So we end up with 5 right here. And then you can tell if you're watching this pattern here, this is going to be third row, first column, third row here, first column there. So we end up with a 6 minus a 9. So that's going to be -3. Doing the next one here, we've got the -6 times the -2. That's going to be a 12 and another 12. So we end up with 24. And let's take a look at this last one here. We end up with a -30 and a 0, so this is -30. So again, that's the answer right there. They take a little bit of time, but they're not too bad once you get used to them. So let's take a look at this one. This one has 3 rows and 2 columns. This one has 2 rows and 2 columns. The inner dimensions are the same, so the resultant is going to have 3 rows and 2 columns. So we're looking for something like this. All right, so I got my blank spaces in there. I'll make that one look just a little bit better. And then we're going to take first row, first column. First row, first column. So first row with the first column. So that's going to be an 8 minus a 3. We end up with a 5. Next one, so first row, second column. So this is going to be a -12 plus a 4. So that's going to be -8. Second row, first column. So second row and first column. We're going to be here and here. That's going to be 16 minus 3, so that's going to be 13. Now we've got the second column right here, so this is going to be -24 plus 4, so that's going to be -20. And now we're on the third row. Again, a little bit tedious here, but we can do this. We're multiplying here, so that's a -16, and we got a 0 out of that, so that's just going to be -16. And then this one's third row, second column. So we get a 24 and a 0, so that's just a 24. So we've got those right here. Again, if you want to leave those blanks in there, I don't have a problem with that. If you can do it without, that's awesome. Let's take a look at this one. We've got a 2 by 2 here. We've got what have we got here? 3 rows and 2 columns, so 3 by 2. Those inner dimensions are not the same, so we're going to put NA here. You can't do that. And the reason is inner dimensions, not the, whoops, make that look right, not the same. So the inner dimensions are not the same. Those inner dimensions have to be the same in order to be able to multiply these. You've got to have the same number in the row as there are in a column. So that's why the columns in this one have to match up with the rows in that second one right there. Okay, let's take a look at the other side. Okay, on the other side, we're on problem number 15. The instructions for these problems say find the inverse of each matrix. If it does not have an inverse, state why. So again, got to have some reasons if we can't answer the question. So this is a square matrix. It's a 2 by 2. 2 by 2 inverses are pretty easy to find. The first thing we want to find is we want to find the determinant. So the determinant on this one, we'll just do diagonals. That's really easy on the 2 by 2s. So this is going to be a -9. And then we'd subtract whatever we get going up, so that's going to be a 2. So we end up with -11. We're going to keep that in our back pocket for a second, because remember, the formula for this is 1 over the determinant. So 1 over the determinant is 1 over -11. And then we have to flip these around. These two literally switch places. So this is going to be the -3 is going to switch there, and the 3 is going to switch there. And then each one of these stays where they are, but they become the opposite sign, the sign opposite of what they used to be. So this one used to be a -1, now it's a 1. This one used to be a -2, now it's a 2. Now we're not done with this. We could leave the scalar out front, but we usually want to go ahead and move this around. So here's what we're going to do. We're going to multiply through. So each one of these gets multiplied by the scalar of 1/11. So negative times a negative is a positive. So this is going to be 3/11. Negative times a positive is a negative, so this is -1/11. And you'll notice because the numerator is a 1, we're basically just putting each one of these on the top. So this is going to be -2/11. We're going to multiply here, and that's going to end up being, so we've got a -3/11 there. Always a good idea, especially when we've got these fractions and a negative floating around here. Notice that we've got a negative here. That one turns out to be positive. And then these other three, they were positive. Now they're negative because we multiplied by that negative scalar. So that right there is our answer. We'll do this one now. Go ahead and do the downward multiplication. So this is going to be 20, and then we're going to put minus, and going with the upward multiplication, that's going to be 20, so we end up with 0. So what we say there is, can't do this, and the reason we can't do that is determinant is equal to 0. If the determinant is equal to 0, then we're not able to find the inverse because we've got to do 1 over the determinant. That would be 1 over 0, which isn't defined, so that means the inverse isn't defined here. Okay, let's take a look at this one. Again, downward diagonal, so this is going to be a, let's see, what have we got here? That's a -4. Then we're going to subtract the upward diagonal. The upward diagonal is a -5. So this ends up being a plus, so we end up with a 1, which is good news because if we do 1 over the determinant, we end up with a 1, and then all we have to do is these, again, switch places, -4 here, 1 down here. These change to the opposite sign, so this is going to be a 5, and this is going to be a -1. So we end up with, well, if you multiply by the 1 over the 1, we end up with -4, 5, -1, 1, and that right there is our answer. So pretty nice little deal there. All right, let's go ahead and take a look at this one. Determinant on this one's easy, so this is going to be a 0 going downward minus whatever we get going upward, so that's going to be a 3. So the determinant here is -3. So we're going to have 1 over -3, so we're probably going to end up with some fractions here. And then again, switch places on this downward diagonal, change signs here, so whatever they used to be, we change to the opposite. And then we're going to multiply through, so we end up with, let's see if we multiply by 0, well, this is nice, we end up with a 0. This is nice also because negative times negative is positive, and 1/3 of 3 is 1. We're going to end up with a positive on this one, so that's going to be a 1/3. And then when we multiply here, that's going to be a positive 2/3. And I'm going to erase that little bar and make that look a little bit nicer. And there we go. So we're all set with that one. Let's take a look at these guys here. Here we need to find the determinant again, but these are 3 by 3s, so a little bit more complicated here than finding the determinant of a 2 by 2 like we had to find the inverse on those problems up above. So it does say find at least one using expansion by minors. So on this one, let's take a look. I'm going to go ahead and do this one using diagonals. Again, if you want to do that crisscross pattern where you double back and things like that, that's totally okay. I do find it easier many times, and it's a little bit easier to keep this straight by rewriting those first two columns. So we're going to write down the -3 and the 4 and the 4. And notice how I've kind of got these equally spaced. So I'm going to go ahead and do that downward multiplication. This is going to have a 0 in it, so that's a 0. And remember, anytime we multiply downward, we're just combining those together. We're literally adding them together. So this is going to be, I'm going to multiply those together. That's going to be 25 times 3. So this is going to be a, what have we got here? Plus 75. Yep, because there's two negatives. And then multiplying downward here, there's only one negative in that one, so this is going to be a negative 8. And again, I did this one, and this one. That's how we got each one of those answers. Going downward, we're going to leave whatever the sign is alone. And then when we're going in the upward direction, I kind of like doing it in parentheses here. So I'm going to put a minus in front, and then I don't have to worry about counting how many negatives there are, with this extra negative in front here. So we're going to multiply upward like this for each one of these. So this is going to be, let's see, that's a 20 times 2, so this is going to be a 40 there. So the first one, upward diagonal, is a 40. This is going to be 15 times 4, so that's going to be 60. And that is positive here because there's two of them, so that's going to be plus 60. And then we've got a 0 in that one, so I'm just going to write plus a 0 on there. So we've got those three upward diagonals there. And let's see what we've got here. So what I like to do is let's put these two together, or these three if you want to think of it that way. So this is going to be 67 minus whatever we get inside here. So this is going to be minus 100. So 67 minus 100, we end up with a negative 33. So the answer on that one is negative 33. Again, lots of calculations to keep track of here. Make sure you're careful with that. This one right here we could do using diagonals again. I'm going to do this one using minors. I like that method better. So here's what we're going to do. Remember, we've got this checkerboard of pluses and minuses. It's plus, minus, and so forth, and then minus, plus. So here's how the minors work. I'm going to expand along because these are the smallest numbers, I'm going to expand along the first column. So we're going to take the 1 along with the sign associated with that position, which is a positive. And then remember, we cross out the row in the column here. So we're going to write down a 2 by 2 determinant made up of what's left. So this is a -4, -5, 5, -1. Make that look like it's supposed to so I don't mess that up. Then we're going to, again, going down this first column here, we're going to put the 2. We put the sign associated with the position, not the sign of the number, the sign associated with the position. So this one's here is going to be a negative. Okay, and then we'll do this guy right here. So we're crossing off the row and the column. So -5, 2, and then 5, -1. And then the last one, of course, we're going to put the number, which is -1. The sign associated with that position would be right here. So it's going to be positive. In other words, it doesn't change the sign of that. And let's see, when we cross out the row and the column, we end up with -5, 2, and then -4, -5. Now, again, if you want to go through and do this using diagonals, that's totally okay. Let's see what we get here. So this is going to be 1 times downward diagonal is 4 minus the upward diagonal, which is -25. And then we're going to have -2. Downward diagonal is 5 minus the upward diagonal, which is 10. And then -1, downward diagonal is 25 minus the upward diagonal, which is -8. Okay, so we're going to add those together. So this is going to be 1 times 29. That's going to be a 29. Let's see, this is going to be a -5, so that's going to be plus 10. And then these two together, let's take a look and see what we get here. That's a plus, right? Because that was a minus. So this is going to be a 33. So this is going to be a -33. So we get 39 minus 33, so we end up with a 6. Again, diagonals or minors doesn't make any difference. Should get the same answer either way. So on number 21, I'm going to go back to the diagonal method. Let's see. So we're going to do 0, -5, 5, and we're going to do -1, 1, and 2. Multiplying downward, it's kind of cool when there's a 0 in there, because if I multiply down here, I get a 0. Multiplying down here, we get a -25. And multiplying down here, let's see, this is -20 times 2, so that's going to be -40. And then we're going to write minus whatever these upward diagonals were. So I did down here, down here, down here. So we're now going to come back and do those upward diagonals. So let's see what we get going upward for this one, and this one. So we get a 20, all right, and then this one we get a 0, and then this one we get, let's see, what have we got here? So that's going to be a, gosh, what have we got? We got a 5. Yeah, we got a positive 5. So let's see here. We're going to go through and we put these together. We get a negative 65. And then this is minus, this would be 25 here, so minus 25. So we end up with negative 90. All right, so pretty easy. Again, doesn't matter which method you use. Sometimes it seems like it's easier doing diagonals. Sometimes it may be easier doing this one. And I'm going to show you an example right now on 22. You could do diagonals. If we get stuck on diagonals, that's totally fine. But on this one, if you take a look here, because this one has 2 zeros, if we expand along that second column right here, so I'm going to set this up completely and then show you how you can take a quick little shortcut. The number that's right here is a 0. The sign associated with that position is negative, and if we cross out the row and the column, we've got a 3 and a negative 5 and a 5 and a 2. Well, this is going to be 0 times whatever that is. Then we've got this one right here, so we've got the negative 2, and again, the sign associated with that position, this would be plus, minus, plus, minus, plus. That's going to be positive. So then we're going to cross out the row. Let me get rid of this stuff right here. We're going to cross off the row and the column. So we're going to have a 3 and a 4 and a 5 and a 2. Okay. Now, if I did this last one right here, so if I did the 0, this would just be plus a 0. So you'll notice that I really don't need to write this one down, and I don't need to write this one down. This is just going to be negative 2 times, and then this 2 by 2 determinant. So this is a really quick way to do this. This is going to be a 6 minus a 20. So let's see, we get negative 2, negative 14, and we multiply these together and we get 28. Now, I'm going to erase really quickly what we did not need. If you know you've got a 0, we could actually do this. Okay, whoops, sliding around here. Whoops. Oops, we were jumping around there. So take a look here. If we're going to expand on this column right here, again, because that's a 0 and that's a 0, we don't even need to calculate those minors. All we need to do is do the negative 2, sign associated with that position is positive, and then do the 3, 4, 5, 2, do this quick little calculation. So I think if you take a look at this, you'll notice that of all of these, this is probably the quickest one. So pretty cool when we've got a couple of zeros. Okay, let's take a look at the other side. Last page, 4 more problems. They're going to take a little bit though. It says write an augmented matrix for each system, then solve using row operations by hand and show your work. So we're going to take this one and we're going to write that augmented matrix. So here's what we're going to do. We're going to write down 3, negative 6, 9, and negative 9, 2, negative 27. Now I sometimes forget this little line right here, so if I do that, don't worry about it. First thing we're going to do is we're going to turn that into a 1, and that turns out to be pretty easy on this one because each one of these is a multiple of 3. So I'm going to write down the shorthand for this. So we're going to do 1/3 times row 1. Draw a little arrow, and I think maybe I can stack these vertically. So here's what we get. If we stack those vertically, we've got this 1/3 times this, 1/3 of that would be 1, 1/3 of that would be negative 2, and 1/3 of that would be 3. And then we've got the negative 9, the 2, and the negative 27. Again, if I didn't mention it in the command right here, that row does not change. So the only row that changed was row 1. The next thing we're going to do is we're going to use this one to turn that into a 0. So the question here is, what do I add to negative 9 to make it a 0? Well, I need to add a 9. So we're going to do 9 times row 1, and we're going to add it to row 2. And again, it's always the last one that's mentioned that changes. So I'm going to do this. I'm going to show a little bit of work here. I'm going to multiply this by 9. So I get a 9, I get a negative 18, and I get a 27. And now we'll go ahead and add these together. So see what we get here. Now remember, row 1, we like that. That's not going to change. So 1, negative 2, 3. And then when we combine these together, we get a 0, which is what we want. We put these together, we get a negative 16. And we put these together, and we end up with a 0. So that's looking good here. Now you'll notice that I have forgotten to put these lines right here. So again, sometimes I just leave them off entirely and then put them back at the end. So now we want to turn this into a 1. We've got our 1 here. We use that 1 to make it a 0. Now we've got to put a 1 in this column right here in that position. We want that downward diagonal there to put it in reduced row echelon form. So we're going to do, this is going to be negative 1/16, because if we multiply this row by 1/16, it's going to turn that into a 1 times row 2, and the negative is going to turn it back to positive. So here's what we end up with. We've got a 1, a negative 2, and a 3. And if we multiply each one of these by negative 1/16, that stays a 0. This turns into a 1, and that stays a 0. And then we're going to turn that into a 0. So to do that, again, the question here is, what do we add to negative 2 to make it a 0? We add a 2. So we're going to do 2 times row 2, and we're going to add to row 1. And again, it's row 1 that's going to change. So if I multiply this by 2, I get 0, I get 2, and I get 0. So we like row 2. That gets to stay the same. And then when we add these together, we get a 1. Add those together, we get a 0. And add these together, we get a 3. And that's the answer. So we've written down all of those commands that it took to get this in reduced row echelon form. The answer on this one is 3, 0. We'll circle that and we're done there. So let's take a look at this one. You'll notice that there's a problem with this one. We have the x on the other side. We always put them in what we call standard form. So we have the x and the y on the same side in the same order, and then the constant on the other side. So I need to move this over to the other side. So here's what augmented form would look like. This would be a negative x over there. So the way I move that onto the other side is I subtract x. So I'll just put a little cross right through there. So this is going to be negative 1, negative 12, and then we're going to have a negative 16, and then we've got a 2, a negative 2, and a negative 20. Okay, so I'll go ahead and put that in the brackets. We've got our augmented matrix here. I'll go ahead and put that line there, try and remember that. First thing we want to do is we want to turn that into a 1, so we're going to do negative times row 1. So all we're doing here is we're just changing the sign of each one of these. So that's going to be a 1, a 12, and a 16. And we've got a 2, and a negative 2, and a negative 20. Now we want to use that 1 to make that a 0. So again, we ask, what do we need to add to 2 to make it a 0? That would be a negative 2. And we're going to use this 1 to make a negative 2. So we're going to do negative 2 times row 1, and we're going to add it to row 2. Again, I'll show a little bit of work here. So this is negative 2, this is negative 24, and this is negative 32. I think that's what we've got there. And then we'll go ahead and combine those. And again, we like row 1. There's nothing wrong with row 1, so we're going to keep that 1 and 12 and 16. Combine these, we end up with a 0. Combine those, we end up with a negative 26. Combine these, we end up with a negative 52, which looks really awful until we take a look at this and realize, okay, we've got a 1 and a 0, which is what we want, and now we want to turn our attention to this. And oftentimes to turn that into a 1, we end up multiplying by some fraction, or dividing, if you want to think of it that way. And the cool thing is 26 goes into both of these. So we're going to do negative 126, because we want to turn that into a positive, times row 2. So we end up with, again, we're not touching row 1. And then row 2 is going to be 0 times negative 126, that's 0. Negative 126 times negative 26, that would turn into a positive 1. And then we've got a negative times a negative, that's a positive, and 52 divided by 26, or 126 times 52. Again, if you need a calculator, go ahead and grab one. You're going to end up with a 2 there. So we're at this point here, and then we've got one thing left to do. We need to turn that into a 0. So we're going to use this 1, and we ask ourselves, what do we need to add to 12 to make it a 0? Well, that would be a negative 12. So that tells us what number we're going to multiply by. So we're going to take the second row, we're going to times it by negative 12, and we're going to add it to the first row. And again, I'll show a little bit of work here. If we multiply this row by negative 12, we get 0. This is negative 12, and this would be negative 24. Yep, when we multiply there, that's what we get. So again, row 2 is fine. We like that one. We're actually done with that row right there. Now we use that multiple here, so we add these together. So this is going to be a 1, that's going to be a 0, and this is going to be a negative 8. So negative 24 plus 16 is negative 8. So again, I left that off, but I'm going to go ahead and bring it back. This is the x column. There's 1x, and it equals negative 8. This is the y column. There's 1y, and it equals 2. So the answer on this one is negative 8, 2. We'll go ahead and circle that, and we are all set to take a look at the last ones. These last problems are very similar. It says write an augmented matrix for each system, then solve them using row operations either by hand or with your calculator. be sure to write your steps. Well, we just did 2x2s up above by hand, so let's go ahead and grab the calculator and let's do these on a calculator. First of all, you'll notice that this is in the correct format, and we do need to write down an augmented matrix. So I'm going to go ahead and write down 3 and 16 and negative 3, and then negative 2 and negative 8 and 2. And then I will put that line there. And then I've got some space here. I'm going to write down the commands that we'll use, and then we'll come back and take a look at number 26. So I'm going to pull up the calculator, shrink this down just a little bit so we can see what we're working with here. And we're going to clear it off, reset it if you need to. We're interested in the matrix menu, and the matrix menu is right here. So we have to hit the second function key in order to access that. So we're going to hit second matrix, and we want to edit. So right now the default is 1 by 1, but this is a 2-row and 3 columns. So we're going to do 2 by 3, and then we put in these numbers 3, 16, negative 3. And then we put in negative 2, negative 8, and 2. And if you were paying attention during the unit, I always said it's nice to double check here. I put them in rows. We're going to double check in columns. So 3, negative 2 looks good, 16, negative 8 looks good, and negative 3, 2. Looks like we're in pretty good shape here. So I'm going to go ahead and exit. We're going to hit second quit. We're going to go back here. And again, always a good idea, always a good idea to make sure that you've got the right stuff in the matrix. One last time, we're going to display the matrix. There it is, double check. And now we're going to go ahead and do our work. So we're going to use the calculator to do the work, and we're going to put our shorthand over here. We need to turn that into a 1. Well, there's a pretty convenient way to get a 1 here. Lots of different avenues here. These are just some general steps. If you see something different, that's totally okay. I'm going to go through some of the most common ones, kind of the way I see them first after doing a lot of practice on these. This can be actually pretty fun because it turns into a mental game, and then we just tell the calculator to do all the hard work. So let's take a look at this. If I want to turn that into a 1, if I were to just add these together, I'm all set to go. That would turn that into a 1. So I'm going to take row 2, and I'm going to add it to row 1. So we're going to pull up the commands here. So we need matrix. We're going to do some math. So we go over, and remember, we just hit the up arrow, and they're the ones that we need. We're going to be adding rows together. So I do have to hit the times row add command. And we're really not changing row 2 at all. So I'm going to do 1, comma. So we're going to multiply by 1. And then we have to tell it the name of the matrix that we're working with. So that's the matrix A, comma. Row 2 is the one getting multiplied, and row 1 is the one getting changed. If you want to put a parentheses on the end, you can. I normally don't because it'll just go ahead and do it without. Again, make sure that it did what you want. We wanted to turn that into a 1, so we're in good shape there. Always store the answer because you haven't made it a mistake and you haven't done any work unless you store that answer. So I'll go ahead and store that. So here's what we're working with now. And again, I'm kind of leaving this behind, and then I'm going through. In fact, I'm actually going to write this down here, R2 plus R1, and we'll keep all those listed down here. So let's see, we want to turn this into a 0. So what do we add to negative 2 to turn it into a 0? Well, that would be a 2. So we're going to take 2 times row 1, and we're going to add it to row 2. So we grab that times row add command, which you can make from scratch if you want to, or remember, your calculator has this deep recall. Get those thumbs going, or you can actually go up and find it. But we're going to multiply by 2. And some people are pretty good at putting these in backwards. I'm going to put in the 2. We're going to multiply by 2 in the matrix A. Row 1 is the one that's getting multiplied, and then row 2 is the one that's going to change. So we're going to go ahead and hit enter. Notice that it did what we want, so we're in great shape there. So I'm going to recall that store command instead of creating it from scratch. Stored that work, and now we want to turn that into a 1. And again, a lot of times we end up using fractions here, so we need to multiply by something. To turn an 8 into a 1, we need to multiply by its reciprocal, so that would be 1/8 times row 2. And we don't have a times row command yet, so we're going to go and type that from scratch. So matrix math, hit the up arrow, grab the times row. We're going to multiply by 1 divided by 8, comma, in the matrix A. And we're going to multiply by row 2. Hit enter. Okay, now that did what we want, so we're in good shape. So again, we'll recall that store command. Store that, and we've got that one. So we're almost there. We're going to turn that 8 into a 0. What do we add to 8 to turn it into a 0? That would be negative 8. So that tells us what number we're multiplying by. we're multiplying row 2 by -8, and we're going to add it to row 1. Again, row 1 is the one that's going to change. Now, this might be back here a ways. If you want to type it from scratch, that's totally okay. It doesn't take very long to go back and find that. Okay, I'm going to actually type this in backwards. We're going to put a 1 here because that's the last one. We're going to put a 2 here because that's the one that's getting multiplied. And then you'll notice that I need to fit in a -8. So I'm going to hit second insert. Notice the cursor changes. Type a -8. I'm going to delete that, stare at that for just a second. This is a times row add command, so we can see that on the screen. We've got what we want. We hit enter, and there we go. So again, just to make sure I don't lose this, I'm going to store that, and there's the answer right there. So we started off with this augmented matrix. We did these 4 commands, or told our calculator to do those 4 commands, and we got 1, 0, -1, and then we've got 0, 1, 0. Close that off, put the bar right there, and there's the answer. We've got 1x and it equals -1. We've got 1y and it equals 0. So the solution on this one is -1, 0. We'll go ahead and circle that. Now, we're going to turn our attention to number 26. So I'm going to zoom in on this just a little bit. This is going to take a little bit of work here. So I'm going to make sure that we've got room and we can see what's going on. So I've got this all cleared off and got it ready to go. We do need to write down the augmented matrix here before we put it in the calculator, but I'd like you to take a look. Before we just blindly write down what the augmented matrix would be, let's think if we can do anything to help ourselves out here. Notice that this one is a 1x. And because that's a 1x, let's go ahead and flip-flop the 2 of these. So let's change places with those 2. So I'm going to write the second one first. So this is going to be a 1, a -2, a 1, and an 8. And then I'm going to put this one here. So this is going to be a 2, a -1, a 2, and a 10. And then, of course, that third one didn't change positions at all. So we've got a -1, a 2, and an 11. We'll put that line right there. And again, always a good idea to make sure that you've got that written down correctly. So let's just take a second to double check that. I think we're in good shape. So let's go ahead and put it in the calculator. So we're going to hit second and matrix. We're going to go over and edit. We need a, let's see, we've got a 3-row and 4-column matrix. So 3 by 4. And notice I'm just hitting enter. I don't need to arrow over there. So we're going to do a 1 and a -2 and a 1 and an 8 and a 2 and a -1 and a 2 and a 10. And then we've got a 3 and a -1 and a 2 and an 11. Again, let's double check here. We've got a 8, 10, 11. We've got a 1, 2, 2. Check the front here, -2, -1, -1, and 1, 2, 3. Okay, looks pretty good. So we're going to hit second quit. We're going to display the name of the matrix one more time, take a good look at it, make sure we're good to go. Looks like we're in good shape, so let's go ahead. We've already got goal number 1 taken care of. We need to use that 1 to turn that into a 0 and that into a 0. So let's see, what do we add to 2 to make it a 0? So this is going to be a -2 times row 1, and we're going to add to row 2. So let's go ahead and do that. Now, again, you could type it from scratch, but we've got this sitting back here a little bit because we just did one of these a few minutes ago. So let's see, this needs to be a 2, so go ahead and edit that. That needs to be a 1, and then we're multiplying by -2, so good thing we've already got a place for it. So we've got, we're timesing a row and adding it to another one, so -2 times row 1 and adding it to row 2. Again, if this didn't work out the way we want, we just don't save it, and then we wouldn't have made a mistake. So I like what it did, so we're going to save that. All right, and there we go. And then notice the next one, all we need to do is turn that into a 0, so we're going to add -3. So -3 times row 1 and add to row 2. And I think when we talked about this before, we said you could actually write these commands down at the same time and then just kind of work your calculator for a few minutes. So again, that's going to, oops, that should be a row 3 here. Let me make sure we grab that. There we go, that's a 3. So we're going to change that to row 3 because we're changing that one. Row 1's the one we're multiplying. And then here we've got, let's see, this is a -3. So -3 times row 1 and add to row 3. So it looks like we're in good shape. We're going to go ahead and hit enter. Did what we want, so we're going to save that. Hit enter, there we are. Okay, now we're right here. We've got the first column taken care of, the 1 and the zeros. Now we want to turn that into a 1. And notice that everything here is a multiple of 3, and that's already a 0, so we're in good shape there. Even if it didn't go in evenly, if it was a 7 or something like that, we're still going to multiply this by 1/3. So we're going to times that row by 1/3. So this is 1/3 times row 2. Make sure that looks good. So I'm going to go ahead and build that command from scratch. So we're going to go ahead and times a row. So we're going to times the row by 1 divided by 3. And the matrix is A. And the row we're multiplying by is 2. That's the one that's going to change here. It did what we want. So again, I'm going to come back here and quickly grab that store command. Now we're going to use this 1 to turn each one of those into a 0. And I'm going to write these down at the same time. So I'm literally just staring right here and thinking, okay, I need to use that 1 to turn that into a 0. Well, I need to add a 2 to this. So I'm going to do 2 times row 2, and we're going to add to row 1, because that one is row 1. And then we want to turn that into a 0. So this is going to be -5 times row 2, and we're going to add that to row 3. And back here just a little ways, not very far, was a times row add command. So I'm going to type in this one right here. So this is going to be a 1, and this is going to be a 2. And then at the beginning, we need to make that a 2. Now, we may have talked before about why it might be smart to do this one first, since we already had a space for the negative, but let's go ahead and do this. We've got a 2, row 2, and row 1. Hit enter. Notice that it did what we want, so again, we'll save that. Hit enter there. And now we're just going to go ahead and type that other one, and we hardly even have to look at this. Let's see, that needs to be a 3. That is row 2, so we're in good shape there. And then I need this to be a -5, so I need to make some space. So we'll do a -5, hit delete there. Looks like we've got everything in there, so we'll hit enter. Looks like it did what we want. Okay, so we have to store. Don't forget to store. A lot of people do that. Okay, now we're really close here. We need to turn that into a 1, a positive 1. So we're going to multiply this one by a -1. But if you stop and think for just a second, yeah, let's go ahead and do that. So we're going to do a -1 times row 3. There are some other clever things that you could do, but I don't want to get confusing or anything. So again, I'm going to go back and we're going to grab that times row command. It's back here ways, and again, you just kind of have to weigh what's going to save you the most time here. So we're multiplying by -1 and delete that, and we're doing that to row 3. So we'll hit enter there, and that did what we want, so we're in good shape there. Again, store that, and we are just one command away from being done with this. We need to turn that into a 0, so that might give you a hint on that little shortcut you could have taken a second ago. We need to add a -1 to make that a 0. So -1 times row 3, and we're going to add that to row 1. So add to row 1. And again, we've got that command just back here a little ways. So I'm just going to go back and find that. Go back just a little bit. And then I'm going to change these going forward. So we've got the negative. That needs to be a 1. And we're doing row 3. Gets multiplied by -1. And we're changing row 1. And we'll hit enter there. Okay, all right, there we go. Okay, so again, store that one last time so we know we're not going to lose it. And then we'll write down the answer here. So the answer on this one is, in augmented form, 1, 0, 0, 1, 0, 1, 0, -2, 0, 0, 1, 3. Put that there, put the line on that one. There's the X, there's the Y, there's the Z. So each one of these represents each one of, so we've got an X column, a Y column, and a Z column. So that means we've got a 1 for the X, a -2 for the Y, and a 3 for the Z. We'll circle that. There's our work. We're all set to go. So I'm going to go ahead and make this a little bit bigger here so we can kind of see what's going on. If we take a look at this, this does seem like one heck of a lot of work. A lot of stuff going on here. But if you're careful, you can make this work out. I know it takes a while to do the practice test here. Test is going to be quite a bit shorter than this. Work hard on this. Make sure you ask questions if you've got them, and good luck.